turns out that we don't have to always integrate with respect to x. We can integrate with respect to y. So notice we have a dy here, which means the variable we're integrating with respect to is y. So how do you do that? Well, if you have x as a function of y and x as a other function of y, so we have f of y and g of y, we're kind of turning our head sideways. Instead of thinking of top and bottom like that, we're actually thinking right to left or left to right. So if I have something like this, for example, I can think of the line as the quote-unquote top function, but it's really the function that's on the right, and then the bottom quote-unquote bottom function is actually the function that's on the left. And so the top quote-unquote top function would be my f of y, and the bottom function would be my g of y. And the same kind of thing works. Top function minus bottom function, integrate it. But again, top means right and bottom means left. Let's see what this looks like in a fresh example, and then we'll go back to that other example we started and didn't quite finish. This example is asking you to find the area of the region bounded by y equals x cubed, y equals x plus 6, and the x-axis. Okay, quick graph of x cubed. Let's see, we have 0, 0, 1, 1, 2, 8, and -1, -1, and then -2, -8. So it's going to go something like this. It's not the best drawing, but I think it'll be good enough. But let's try a better one. There we go. That's a little better. The thing that was bothering me about my first version was I wasn't making it flat enough at 0. Because if you remember when we were doing stuff with tangent lines, if you were to take the derivative of y equals x cubed and set it equal to 0, you would get that a critical point is 0. And in other words, you would get a place where the derivative is 0 at x equals 0. So you should really make it look like it's going to have a flat horizontal tangent line there when you draw it. I mean, to be correct. All right, what about x plus 6? That's going to be standard line, except it's going to be shifted up 6. So I'm going to make a bunch of points there. Okay, and then let's see, what do we have now? Oh, the x-axis, which means we're being asked to calculate this area here. Now, using this new idea of, instead of thinking top minus bottom, thinking right minus left. So if we want to think of right minus left and putting x in terms of y, we need to think about what is x cubed as a function of y rather than a function of x. Right now, when you say y equals x cubed, you're writing y as a function of x. But if we solve for x, which in this case is as simple as taking the cube root of both sides, we will get cube root of y is equal to x. So now we have x as a function of y. And as you can see, it's the quote-unquote top function because it's the function on the far right. Now what about the x plus 6 function? Y equals x plus 6 is originally being written as y is f of x, where f of x is x plus 6. Maybe I shouldn't use the letter F. I hope that's not confusing. Y is function of x. How about that? And function of x is x plus 6. How do I make x a function of y? Well, I just solve for x, which would involve just subtracting 6 from both sides. So now I have x is g of y, and that's the bottom function. In other words, it's the leftmost function. Now we just need to figure out our limits of integration. We know we're going to start at 0, but we need to know where that point is in order to figure out where to end it. So that's kind of hard. Actually, it's not so hard. When I realized that my graph was pretty bad, I said that when x is 2, for the y equals x cubed graph, when x is 2, y is 8. So I don't know what that point's doing there. This is actually a pretty bad picture now that I realize it. But the point is that this graph should have intersected at a more obvious place. In other words, right here. So let me erase that area that we don't need, because that's not part of the area we're calculating. And there we go. So we can hopefully see that we're going from y equals 0 to y equals 8. And we're turning our heads to the side, and we're seeing that there is this quote-unquote top function and quote-unquote bottom function. Okay? If that's hard to do, that's okay, because I can turn it sideways for you. Watch this. Top function is this one. Bottom function is this one. Okay? So let's keep that in mind. I always tell students to turn your head sideways. So I'm doing that part for you. Let's set up the integral. So the area is going to be, now it's going to be a dy integral, because we're doing this sideways thought process. Integral from c to d, which is the y values that our region is spanning. It's from 0 to 8 of, let's see, top function is cube root of y minus bottom function, which is y minus 6. And we're integrating that with respect to y. That's the key point. So I'll show the solution to this integral. You can pause right now, finish calculating it, and see if you get the same answer I did. So take a moment, look at my work. You can pause the video. And my final answer was 28.